Hi, welcome to Unit 8, Lesson 2. So in Unit 8, Lesson 1, we looked at bar graphs, and in this lesson, we'll look at a different kind of graph. We'll look at a circle graph. So remember that when we looked at a bar graph, it was allowing us to compare values that were associated with different categories. In a circle graph, what we're going to be able to do is take a whole and see how each part of that whole compares to the other. So circle graphs, because they show how parts are related to wholes, are going to show that as percents. So because it's easy to look at a circle and kind of recognize where 50% is, where 25% is, because we know what half the circle looks like. We know what a fourth of the circle looks like. So with circle graphs, we use percents. And one important thing to remember with the circle graph is that the percent values in the circle graph will always have a sum of 100 because 100% means the whole thing. So if you were to add up the percents from each little section of the circle graph, those should always add up to 100. Okay, let's jump in here and look at our first example. So in this circle graph, it says kinds of ads on children's TV shows. And we can see that there's a section that represents ads for toys, breakfast foods, fast food and drinks, and then other products. And then we can see how each of those compares to the other. For example, I can look at that circle graph and see that toys seems to be the most popular ad on children's TV shows. It's a little more than a fourth. It's taking up a little bit more than 1/4 of that circle. Fast food and drinks and breakfast foods are each taking up a fourth, which means together those are 50%. So it's very easy to look at a circle graph and see how the parts relate to the whole. So the question says a total of 180 ads were shown during children's TV shows in a recent time period. Based on the graph, how many more of those ads were for toys than for breakfast foods? So we're told that there were a total of 180 ads. And we want to focus on ads for toys and ads for breakfast foods. And it says how many more ads were for toys than for breakfast foods. So I know when things say how many more, that means I'm going to subtract. I'm looking for the difference between the two. It's tempting to just grab the numbers from the graph and subtract those, but those are percents, and it doesn't want the difference between the percents. It wants the difference between the actual numbers of ads themselves. So we know here that our total number of ads is 180. And we know that 35% of those were toys and 25% of those were breakfast foods. So I could think, well, 35% of 180 is toys, and 25% of 180 is breakfast food. So if I want the difference between those two, then I need to find 35% of 180 and 25% of 180. So let's look at that. So 35% of 180, so 180 times 1, 2, 35 hundredths. 5 times 0 is 0. 5 times 8 is 40. 5 times 1 is 5 plus 4 is 9. Move over. 3 times 0 is 0. 3 times 8 is 24. 3 times 1 is 3 plus 2 is 5. And then we'll add 1, 2, 1, 2. So 63 ads were for toys. So now we need to look at 25% of 180 because 25% of the ads were breakfast foods. So we'll do 180 times 0.25 or 25 hundredths. 5 times 0 is 0. 5 times 8 is 40. 5 times 1 is 5 plus 4 is 9. Done with the 4. Move over. 2 times 0 is 0. 2 times 8 is 16. 2 times 1 is 2 plus 1 is 3. Now we'll add. And then take care of the decimal. 1, 2, 1, 2. So 45 ads were for breakfast foods. So if I want the difference between the two, then I want 63 minus 45. And that'll give me the difference between the numbers of ads. 13 minus 5 is 8. 5 minus 4 is 1. So there were 18 more ads for toys than for breakfast foods. Okay, next example. This circle graph shows us Milton's family budget. And we can see that they spend 33% on food, 25% on rent, 6% on savings, 15% on clothes, and then 21% for miscellaneous. So we can kind of see how each part relates to the whole. It says, if the Milton family has a total monthly income of $3,750, how much more do they spend on food than rent? So again, we have our total, which is $3,750. I want to focus on food and rent. So 33% and 25%. So let's find 33% of 3,750. Not 35%, 33%. Okay, 3 times 0 is 0. 3 times 5 is 15. 3 times 7 is 21. Plus 1 is 22. 3 times 3 is 9. Plus 2 is 11. And we'll move over. 3 times 0 is 0. 3 times 5 is 15. We're doing the same thing. 3 times 7 is 21. Plus 1 is 22. And 3 times 3 is 9. Plus 2 is 11. And now we'll add. So for food, they spend $1,237.50. So now we need to look at rent, which was 25%. So 3,750 times 25 hundredths. 5 times 0 is 0. 5 times 5 is 25. 5 times 7 is 35. Plus 2 is 37. 5 times 3 is 15. Plus 3 is 18. And I'm done with those and move over. 2 times 0 is 0. 2 times 5 is 10. 2 times 7 is 14. Plus 1 is 15. And 2 times 3 is 6. Plus 1 is 7. And we'll add. And so for rent, they spend $937.50. So if I want to know how much more they spend on food than they spend on rent, I just need to subtract. So $1,237.50 minus $937.50. And we'll just subtract. So 0 minus 0, 5 minus 5, 7 minus 7, 3 minus 3. Can't do 2 minus 9, so I'll borrow. And 12 minus 9 is 3. So they spend $300 more, and this was monthly income. So they spend $300 more per month on food than they spend on rent. Again, we were just using those percents to find percent of total by multiplying, and then we subtracted to find out how much more one was than the other. Okay, last example. So if, this is Nathan's typical day. So you can tell what percent of the time he spends on each activity. So 8% eating, 22% recreation, 8% homework, 22% school. Now you might notice that sleeping does not show a percent. But remember from earlier in our notes, we said that in a circle graph, the percents should have a sum of 100. So as long as I know all the other percent values, I can figure out that missing one. And that's our first question right here. What percent of Nathan's day does he spend sleeping? So I'm going to add up all of the other things. So I have 22 twice and 8 twice. So 2 and 2 is 4, plus 8 is 12, plus 8 is 20. And then 2 plus 2 is 4, plus 2 is 6. So that's 60% that he spends on the things that were given to us. Sleeping takes up all the rest of the circle graph. So if I subtract 60 from 100, I'm left with the value for sleeping. So he spends 40% of his day sleeping. So not quite half. Okay, so then it says, about how many hours of the day does Nathan spend doing homework? Well, homework is 8%. So he spends 8% of, and it says of a day is 24 hours. So we'll do 24, not times 0.8, go 2 to the left, so times 0.08, because 0.8 would be 80%. 8 times 4 is 32. 8 times 2 is 16, plus 3 is 19. And then there's no need to multiply by that 0 because it will just give me a row of zeros. 1, 2, 1, 2. So 1.92 hours. So we could say he spends about 2 hours. We could round that since it said about how many hours. So he spends about 2 hours a day doing homework. Aren't you glad you're not Nathan yet? Okay, so that is it for Unit 8, Lesson 2. So it's kind of a recap. We used bar graphs in the previous lesson to compare categories. We're using circle graphs in this lesson to see how each part makes up the whole so that we can easily compare each of those parts. And with circle graphs, we use percents, and those percents within the circle graph should add up to 100. If you want to see some more example circle graphs, please ask. If you have any other specific questions, let me know. If ready for the skill check to be open, I'm happy to do that for you. Thanks. Have a fantastic day.